ladies and gents. This is going to be a really simple getting started tutorial on how to make a fan or a turbine in Fusion 360. So here I have my fan, and basically what we're going to do through this tutorial is duplicate this particular fan. From there, you can be able to go a step further and edit the dimensions and whatnot to be able to customize this fan the way you want it for your particular design. So in Fusion 360, just a simple introduction to its interface. Up here we have our main toolbar, which is where we'll be working in. And if you notice, we are currently under the solids environment. We have a couple of environments. We have solid, we have surface environments, mesh, sheet metal, plastic, utilities. But for now, we'll be working inside the solid environment. We will briefly touch or use some tools under the surface, but that will be specific to this particular fan tutorial. Now, when you launch Fusion 360 for the first time, you will likely be in such an environment where it's blank. You may have a grid shown there, or you may not. It might be blank like mine. And usually they start a new design named Untitled. So when working in Fusion 360, basically you want to start with a 2D sketch or drawing and then manipulate that particular 2D drawing to be able to achieve an actual 3D design. To get started, let's first try and make just the 2D sketch that will define this particular arc right here, the root of my fan. This arc here, we can define it in a two-dimensional plane, so I'll come back to a normal design. And the way to start a 2D sketch, you'll use this button right here, Create Sketch. So I'll click Create Sketch, and basically what Fusion wants us to do right now is to select one of these planes to start your sketch on. You can select many other planes in the future, but for now, because we're at the beginning of the design, we only have these three planes that we can start our first sketch on. So I'll go ahead and pick my YZ plane. How do I know it's a YZ plane? Well, I can see this plane lies between my green axis and my blue axis. And if I come over here to my view cube, I can see my green axis is a Y and my Z axis is blue. So this is my YZ plane. And so I can click on it to start my 2D sketch. You will notice that you will now shift from the solid environment I talked about, and now you are currently in a new environment that wasn't there before. It's called a sketching environment because sketches are 2D, and so they have their own environment. So the way we're going to create that arc that I showed you, we'll expand the Create tool here, the Create tab here, and click on Arc. Specifically, we'll use a 3-point arc. Now, another thing to note while working in Fusion 360 is very rarely do you click and drag. Most of the time, you just clicking, and clicking and dragging is only used in a particular circumstance, which I will show you later on in this tutorial. So for now, if I just hover one place, it'll tell me that I need to place the start point. So I'll click to place the start point. And now it's asking me to place, if I hover, place an end point. So I'll click and place the end point. And then now it's asking me to place point on arc. And so I'll just choose an arbitrary location on my arc and I'll place my point. Perfect. Whenever you're done with a command, it'll remain in that command. So right now I can actually start drawing another arc if I want to, but if your intention is not to draw a second arc, you can right click and then press OK. Good, so here we have our first arc in our first sketch. One thing I want you to notice is that this arc is blue in color. And the color of the arc is actually significant in Fusion 360 because it tells you of the state of your sketch. Any geometry that you draw here will have one color or the other. This one is blue, and what light blue means is it is unconstrained. Now, in normal English, a constraint means that something is not free to move. And this particular arc is unconstrained, which means it is free to move. And I can now click and drag this point, and it will show you how this particular arc is free to move. You can see I can drag it in and out, it's changing its diameter, and very many other degrees of freedom. Ideally, in every sketch, you don't want any geometry to be unconstrained. You want everything to be fully constrained. So we're going to work to constrain this geometry such that it can no longer move around. So the first thing I want us to do is to draw a line across from this point to this point. And that line is not going to be a normal line. It's going to be a line just to help us constrain our main arc. Our focus is the arc. So that line will just be there for the purposes of helping us constrain our sketch. And we need to differentiate it from normal geometry like our arc here. So I'll go into the line command, and I will click from this point and click to this point. Remember, no clicking and dragging. Once you're done placing your line, right click, OK. Now this arc currently looks the same as, this line currently looks the same as this arc. And remember, I said I want this to just be geometry to be able to help us constrain our main sketch. So I'll click on that line. Then in my sketch palette tab right here, I have a few options. And one of them is converting the line type to a construction line. So I'll click that construction line, and I can see the line that I don't really want to be part of my geometry, it's just helping me, is now broken. That is how a construction line is defined. So I can use construction lines, construction arcs, construction geometry, or construction parts of my sketches just to help position items and constrain them. Right. Next thing, we are going to try and place the middle of this arc at the center of our design, which is right here. This is known as the origin because it's the center of the design. And you can see how it's the symbol that is showing you. It's an origin, that symbol right there. That's going to be the center of space. And even in our design, it's the center of our sketch palette. Now, I want to try and make sure that the center point of this arc, which should lie somewhere around here, coincides with this point. And the way to do that, we can use some of our constraints up here. Specifically, I want us to use this midpoint constraint, which actually is somewhat self-explanatory because we are trying to constrain a midpoint of an arc. If I hover over any constraint and wait long enough, it'll expand and tell you what that constraint does. So this one constrains a point or object to the midpoint of another object. So I'm going to click my midpoint, and I want to constrain the midpoint of this arc. I don't have to select the midpoint. I don't have to hover around the midpoint. Anywhere on the arc, if I highlight the arc, it automatically knows that I'm trying to select the midpoint of this arc. So I'll click that. And then the next thing, I want to constrain the midpoint of that arc that I just selected to the origin. So I'll click there. And you can see how my arc snaps into place, and now it's constrained the way I want it. Once you're done with that particular constraint, you can right-click and then press OK. Notice our geometry is still blue, so that means it can still move in a couple of ways. Again, to check, I can click and drag, and you can see now it's changing its diameter, it's changing its length as well. So there's still a couple of ways this arc can change. Right, the reason I put this line here is because this is one thing that can help us constrain this arc. What I can do is use a sketch dimension, of which the tool is right here, to dimension this line. Make sure that it's a particular length. So I can click my sketch dimension, click the line that I want to dimension, and then move out. I'm not clicking and dragging. I'm just clicking and then moving my mouse or pointer away off to the side. So again, the only place I clicked and dragged was when I was trying to check out how this arc can move before I started trying to dimension it. So let me just start that again. I'm going to click my sketch dimension, and I'm going to select this line. It was already selected, that's why it's already trying to dimension that line, and I'll click there. Good. Next, I can put in my particular dimension. Say I want this to be 50 millimeters. The default unit for Fusion 360 is millimeters, so even though you don't type 50 mm and just type 50, it'll automatically know that's 50 millimeters, and you can hit enter. Of course, it's going to get much smaller because my space was big, so what we can do, we can just zoom in. Now, I'm currently using a mouse, so that means my middle mouse wheel will help me zoom in. But if you're using a trackpad, the tool right here, zoom, can assist you to zoom. So the way you use this tool, you click it first, then now you can click and drag in and out of your workspace, or up and down actually, and it'll zoom in and out of your workspace. Similar tools down here for your trackpad are your pan tool that can help you pan your page around. You also have your orbit tool, and you can orbit around. Now notice, once I use the orbit tool, it's actually showing me the sketch plane that I'm sketching on. So this is a very nice representation of how we are currently working in a 2D space, even though Fusion 360 is a 3D design software. So we start with 2D, then we'll move to 3D. So to come back looking at it straight from the front, I will just click the right view on my view cube, and now I'm looking at it head on. Right, so I personally will right now not be using these because I have a mouse, and it's advisable to get a mouse to be able to work quickly and efficiently in Fusion 360. Good, so once I'm done with any of these tools, you can right click and then click OK. Another key that will really help you in Fusion 360 is the escape key on your keyboard. So when you press escape, I've done it right now, it'll basically quit any command that was currently active, and your pointer will come back. So in case something strange is going on and you're finding that you're not able to click the way I'm clicking, try hitting the escape key first and then restart your particular command that you're trying to achieve. Good. So back to our arc, we've now put a 50 millimeter dimension on this line. Let's again check how this arc can move. So I can click and now drag this to check that the arc can now swing around, and again my diameter of the arc can still change. So let's first start with the diameter. I'm going to move this back a little bit to there. So the diameter is specified using the very same dimension tool that we used earlier. A diameter, if you think about it, is still a dimension. So I can click it and then click my arc. I click your arc, and you notice it's actually trying to specify the radius of the arc. That's why it starts with R. So right now it's R40.789. So I will click to place the dimension, and now I can edit this. So let's say I want this to be quite a big arc, 100 millimeters. So that's a pretty big radius arc, even though it is short, defined by our tangent chord here, and it's only that chord is 50 millimeters long. So I'm going to right click, then hit OK. Again, I feel like I don't want to be any more in my dimension command, so I'll just hit escape. Good. Again, back to my dragging, I can see that it can still tilt. The diameter is no longer changing, but I can tilt my arc. Now, what we're going to do is try and give this a fixed angle. You can see that if I fix the angle of our construction geometry here, it'll automatically fix the angle of the arc. So the first thing we're going to do is draw another construction line. So line, I'm going to click that point and I'm going to move straight out towards the right. I'm going to lift this up a little bit from the horizontal so I can show you one more constraint. I'm going to right click there, and then when I'm done drawing my lines, right click, OK. I want to make this line completely horizontal, so I will use what is known as the horizontal stroke vertical constraint, still in our constraint tabs. If I click this and I click this line, it'll snap it to the nearest either horizontal or vertical location. And it will add the icon telling you that this constraint, this horizontal one, has been applied to this line. Just like we did the first time, once we used the midpoint constraint, the midpoint symbol was put right there to show you that there's a midpoint constraint working right there. Once I'm done with that command, I can right click and hit OK. Next, this line is not really part of my geometry. Again, I'm really interested in my arc, so I'm going to make that a construction line like we did before. So I'm just going to click that and done. Now I want to specify an angle between this line and this line. And so I will use my sketch dimension tool. An angle is still a type of a dimension, and I'm going to click this line, then I'll click the first line that we had, and then I'm going to move outwards, and then I'm going to click to place the dimension. Maybe I only want this to be a pretty big angle, maybe 80 degrees. Should work. Perfect. Notice changes. Number one, our arc is now black in color, which tells you it's fully constrained. You always want to try and achieve a fully constrained sketch because they're much easier to work with, they're more rigid, they're defined, and later on when you come to now change your design, maybe you have an iteration to do, it's very easy just to change these angles. And that's the end of our first sketch. That's our first 2D sketch. And what we're going to do, once you're done doing any 2D sketch, you can come to the top right here and click Finish Sketch. Now we are out of the sketch tab, the sketch environment that was here. We are back to our solids environment. And I can now look at my design or my 2D sketch from different angles. And because it's just a 2D sketch, I have no geometry. It's because the geometry is now lying on one singular plane. So from there, I want to create a new offset plane so that we can define this edge of this arc right here. So what we've just drawn is this one. Now I want to draw this other one here, offset by a particular distance. So we have this one here and this one here. There's a particular distance in between here. Right. The way to do that is, number one, we first need to identify what plane we sketched on. If you remember, we used the YZ. Yours could be different. But the best way to identify is to expand the origin and to try and hover over the different planes that are available here. We have the XY. If I click on it, it'll just highlight it, and then I can orbit around, and I can see that it's intersecting my sketch plane. So that's not the plane I sketched on. Maybe the XZ, that's the one at the bottom. That's not the plane I sketched on. How about the YZ? Now if I look at this plane, I can see that it's cutting my sketch perfectly parallel, and that's a plane that I sketched on. Now, why do I go through all the trouble of identifying this plane? It's because we want to create an offset plane away from the plane that we sketched on. It'll make sense in a bit once we actually do it. The way we're going to do it is expand this construction tab, and we're going to click on offset plane. Now, right now, the first thing it's asking you to select here, you get this little tab, is to select the reference plane. So I'm going to click on select, and my reference plane is the YZ plane right here. So I'm going to click that. Then how far do I want to offset my YZ from my YZ plane? Maybe 100 millimeters. If you look at it, now you'll understand the offset better. We are offsetting a plane parallel to a reference plane. And that particular reference plane was a plane on which we sketched right there. So once you're done doing your offset by 100 millimeters, click OK or hit enter. So now we have our initial sketch and we have another plane right here. Good. The entire idea of creating this plane is because we want to start a new sketch on this plane. And just like we did before, we'll use the create sketch command. And this time around, we're not going to use any of the sketches at the origin. We're going to click on the plane we just created, this one right here. So your grid should be passing through this one. So I'm going to click there. Perfect. Our sketch is in the first sketch is in the background faintly because it is not part of the current sketch that we're doing. Remember, we just started a new sketch. In fact, if I expand sketches here, I can see I have sketch 1 and I have sketch 2. So I'm going to hide sketch 1 so that it doesn't confuse me. And then in sketch 2, we are going to do exactly the same thing as we did in sketch 1 with only one difference, and I'll show you that difference a bit later. But basically, if you look here, we just want to make another arc on that sketch 2. So I'm going to come back to my tab right here, and I'm going to use the exact same tools to create that arc and constrain it. So remember, I came to create arc, three-point arc, clicked the first point, clicked the second point, moved out a distance, clicked the third point. Then I used my line tool to create a line between here and here. Once I'm done doing my line, I can click escape to exit the line command, press the line that I just created and make it a construction line. Good. Next, I also created a construction line at the bottom, so I'll again use my line command, come from here all the way to there, right click, OK. Now let me pause here a second. If I went straight out, it'll assume that I already want the horizontal constraint, so it added it for me automatically. You can see the constraint symbol is here. So therefore, if I try and drag this line up and down, it'll move in its entirety, but remain horizontal. Good. So remember, this line also needs to be a construction line, so I will do that. Again, I want to use a sketch dimension here to dimension this line and make it 50 millimeters. And I also want to use the same sketch dimension to make this arc 100 millimeters, just like before. Now, again, remember, our arc is now shifting around. Remember, I had it constrained to the origin right here. So I'm going to use my midpoint constraint to constrain the midpoint of this arc to the origin. Perfect. We're getting closer. Next, I'm going to use the sketch dimension to add an angle between here and this construction line that's here. Perfect. And then move your mouse out, then click. Here's the only change I want us to do, because in the last sketch we made it 80 degrees. Here we can do 45 degrees. Perfect. Our geometry is all constrained now because it's all black in color, so I can right click OK and then finish my sketch. Perfect. I can now come back and unhide my first sketch, and you can see I have the first sketch here and this other one here, offset from each other. That's awesome, because now the next step gets even easier. So we are now at a stage where we're now ready to move to a 3D environment. I'm orbiting around my two sketches. I'm already in a 3D environment, so now we want to use our sketches to start making a 3D body. This is one place we are going to use the surface tool, the surface environment. So I'm going to click on my surface environment. I'm going to expand create, and I'm going to use the loft command. Now the loft command, when in the surface environment, allows us to create surfaces between two sketch profiles. And the way it works is I can click this line, the first one that we did in the first sketch, and then I can click the second line in the next sketch. And you can see it creates a surface. Now a surface is just that. Basically, it has no thickness. It has zero thickness. It's just a surface, but we will give it thickness because, of course, our fan blade needs thickness. But for now, the loft is going to help us. So once you're done with the loft, just click OK. Now we have our surface defined there. Nice and pretty. This is going to be our fan blade. Once you're done, you can now come to create, and we're going to use the thicken tool. This, if you hover over it, adds thickness to a surface to create a solid body. That's exactly what we want. So we're going to use the thicken tool to click on our surface and give our surface thickness. In this case, I'm going to use 1 millimeter. Now, let me pause here and explain why I've chosen 1 millimeter, or at least why not any other value. Well, basically you can put any thickness you want, but because this item or this fan that we are designing is going to be 3D printed, there are limitations with the 3D printer. The 3D printer cannot achieve anything thinner than 0.8 millimeters. And so I can safely put 0.8 millimeters there, as I've done, but I don't like to really play on the edge, so I just want to give it a bit of allowance and put 1 millimeter. And so that's as small as I would recommend going. You can make it thicker than 1 millimeter, up to you. In fact, I can just demonstrate. I can put 4 millimeters and it'll make the surface 4 millimeters thick. So let's go back to 1 millimeter. Once you're done, we can click OK. So it's creating a new body. The operation is creating a new body in our thicken, which is the first body that we have. So click OK. And we have our beautiful single fan blade. Now, some of you might be thinking that, oh God, we have to do that all over again. But that's really not the case. Fusion 360 allows you to pattern items in particular directions so that you don't have to make them all over again. So think of it like a fancy way of doing copy-paste, but when it's positioned properly for you. Now, one of those tools, we're going to go back into our solids tab because we're done with our surfaces, and we're going to expand, create, and come to the pattern command right here. The particular pattern we want is a circular pattern because we want multiple of these fan blades in a circular pattern. The way to move from here is now to select the correct axis to pattern around. So what are we trying to pattern? We're trying to pattern a body. We only have one body here, so that will remain as is. And we now need to select the body that we need to pattern. So we're going to click select here and select that body. Then which axis are we going to pattern around? So I'm going to click select here, and that reveals the axes that were at the origin. You can see we have my green axis, blue one, and red one. Looking at it and orbiting around it, it's kind of obvious that we want to pattern around the green axis here, the y-axis. So I'm going to click that. You don't exactly have to click it here. Once you hover over it, you can see the y-axis is highlighted here. So I'm going to hover again. The y-axis is highlighted there. So I can actually click on the y-axis right here. Perfect. Now what you're seeing here is a preview of what it's going to do. So you can see it's going to pattern it around a singular one axis, that y-axis that we talked about. And we can make 4 blades. We can make a pattern of 5. We can make a pattern of 50 if we want, and it'll work, depending on how you want to design. But for now, we're going to do a simple 3-bladed fan design. Over here, there's nothing else for us to edit, so we're going to go ahead and click OK. Good. So now we have our 3 fan blades kind of intersecting at the center. Don't worry about that. We're going to sort that out very shortly. We now want to make our hub. We have the 3 blades, and now we want to make the hub, the central hub where the blades will all be coming out from. So back to our design. Again, once we're done with the 3D, we can go back to a 2D sketch to be able to create a hub. Now we're going to use the create sketch command, and this time around I want us to create a sketch on the XZ plane. That is a plane that passes or cuts through the center of all our fan blades. It's right there, the XZ plane, right here. If you select this one, you'll notice it's not cutting through all the fan blades. It's kind of over there in the middle, and same to this other plane, the YZ. So I want to use the XZ plane. So I'm going to click on that. Perfect. That now means you're looking at it from the top. I can now use my circle command. We have a couple of sketch geometry here, and we already used the line, we've used the arc. Another one is a circle. So we can use a circle, click the center or the origin, and move outwards. Remember, I'm not clicking and dragging. And I'm going to place this point anywhere. Good. Once you're done drawing your circle, right click, OK. Then I'm going to use my dimension tool to put a particular diameter on my circle. You notice how this time round the symbol has changed. It's no longer R. It's actually showing the diameter symbol. So just be aware of that. So you're now specifying the diameter. In this case, I want my diameter to be 30 millimeters. Now it turned black, meaning my circle is fully constrained from being blue. Once you're done doing the circle, let's finish that sketch. And you see how my circle is in the middle of all the 3 fan blades. Now the next command I want to use, now that we're out of the sketch environment and back into a solids environment, is to use an extrude. Now what an extrude does, if I click on it, it's easier demonstrated. Basically, I can click and drag this up and down. So right now it wants to cut through my material. But what if I were to change the operation here in my extrude dialog to a join? So it can join with all the rest of the fan blades that we created. You can see now we are somewhat having our fan, but we're not quite there. We needed to extrude both up and down by a big of a distance. So we'll be more mathematical about this. If you come to extrude dialog, number one of the things you can specify is the direction. Right now we're only moving in one direction, but I can expand this and say I want to move in 2 sides, 2 directions. And then I can say one direction should be 30 millimeters, 30. And then the other dimension right here, I also want it to be 30. Perfect. Maybe 30 looks too much to you. Let's try 25 on each side. Something in between, maybe 27. Yeah, 27 looks good. And so I'll make this other side 27 as well. Right, so the things we changed in this extrude dialog were we moved the direction to 2 sides, we specified one distance, we specified the second distance, and we changed the operation to a join. Once that's all in place, you can click OK. So now we're starting to look like the initial fan we wanted to design. Of course, this one has a couple of changes. It looks a bit different. I did go about and change this one a bit, but our specific geometry is starting to be shaped like a fan, and we're almost home and dry. There are a couple of things left that we can do to be able to make this fan usable or turbine usable. And the first thing is I want to try and put a cone right here. I feel like it'll help my aerodynamics, so I'm going to try and put a cone right here. And that is to make this pointy at the tip. Now the way I'm going to do that is, again, using a sketch, using a 2D environment first, and then using that 2D sketch to make 3D geometry. And so what I'm going to do is I'm going to start a new sketch, and this time I want a sketch plane that literally intersects my fan. I'm going to try my XZ plane, so my XY plane. Yeah, that looks good. And that intersects my fan. If I look at the grid, or I continue orbiting around the grid, I can see it intersects the hub of the fan perfectly the way I want, right in the center. So I'm going to use that. And I want to now start sketching on this plane. Now, in this sketch, I want to use the top part in this sketch. And there's a command for that. If I use the letter P on my keyboard, it'll give me my project command. And what this does is I can project particular geometry to appear in the sketch that I'm working on. So I'm going to click on the surface here, and this surface will be projected as a line on my sketch. So if I click OK, you'll see that I now have a purple line running across the surface. So this is this entire cylinder projected on my sketch plane, which of course is now rendered as a line. And that line will be useful to me. So I'm going to go ahead and now continue sketching. I'm going to use my line, click at the point there, move up, and then come down. Now, I'm not going to reach all the way down because I want to show you one more thing. So I'm just going to click about midway. Once I'm done drawing my lines, right click, OK. I'm going to once again use the midpoint constraint. And this time round, I want to constrain the midpoint of this line. So I'm going to select anywhere along this line, there. And I want to constrain that to this point. It's going to come all the way down. Perfect. Now it's snapped into place. The last thing I want to do is specify how pointy I want this thing to be. So how high do I want my sharp point to be? I'm going to use my sketch dimension tool, and I'm going to dimension this line, and maybe I only want it 20 millimeters tall. So 20, enter, and now remember, look at our geometry, fully constrained, all black. The purple here means that it is projected geometry, which is dependent on this surface that we actually selected. So once you're done with that, right click, OK, then finish sketch. Perfect. Another tool I want you to use, or we're going to use right now, is our revolve tool. And this revolve tool, if I click on it, can revolve geometry around a particular axis. So imagine if I selected this axis right here. So I'm going to click select, and I'm going to try to select this as my central axis. It will revolve that triangle around 360 degrees to make that axis. To give an idea of how the revolve is working, let me just make this only 45 degrees. And you can see it kind of makes like a pie shape. So it's revolving that around that axis. So if I change this back to 360 degrees, it'll revolve and make my sharp point at the top. Once you're done with that, you can click OK, and we have our sharp, pointy fan over there. The last thing we're going to need to do to make our fan usable is place a hole right here so it can enter into the shaft of the generator that we're trying to spin. And this one is about the easiest step that we're going to do. So once more, I'm going to use my sketch tool, and I'm going to now click a sketch. I'm going to try and place a sketch on this surface right here. I'm going to click there. And I will now expand my create tab and click point, because I want to place a point right there. Right click, OK. Perfect. So I have a point right there lying on the surface where I want to drill my hole. And then from there, once I'm done with that sketch, I can do finish sketch. And this time around, we're going to use a hole command. So we're going to use, to use a hole command, it needs to depend on a sketch point. So in the dialog box here, it's asking you how you're going to place it, or placement. And it's asking you to select particular face or sketch points. We just created ours, so we're going to click there. Right, so that's where we're going to do a hole. When it's red, it's going to try and cut through material, so you know it's going to make a hole. And we're going to do some specifics on this hole. Number one, the depth of the hole, I only want it 10 millimeters deep. And then my diameter of the hole, right here, I only want this 2.3 millimeters deep. Now, this is the one dimension I don't want you to change. It's 2.3 millimeters, and that's for a particular reason, because the shaft that's going through here in the challenge is 2 millimeters, exactly 2 millimeters. But 3D printing is not as accurate as you might imagine. So we need to give it a bit of clearance to fit into the shaft. And so that clearance is going to be 0.3 millimeters. So once I have added my clearance, I'll click OK. And I'm done. So this is now ready to be 3D printed. There are a few things that we can do to make this easier to 3D print, but as of now, this is already as basic as it gets. And that is the fan tutorial. So just a recap of what we have done. We tried to duplicate our design right here, and we've used a combination of sketches and our solid tools to be able to achieve that. We also had to use a surface tool, which is not that common in the surface environment, but mostly we stuck to our solids, and we used an extrude, we've used a revolve, and we've used a hole. As you continue designing in Fusion is when you realize that more of the tools on the right become more necessary to use, and usually the more to the right in your toolbar you go, the more complex your design is getting, or complete your design is getting. So with that, thank you for listening, and I hope this tutorial makes sense to you and will help you achieve all your fancy fan blades. Have a good one.